Hello, how are we?
I'm good, thank you. How are you doing? Am I
I
audible?
don't think the connection's incredible, but we'll see how it goes.
The whole toroidal concept is very fresh in the market. Uh, it's only 22 when MIT came up with this idea. However, if you might have dug a little deeper, you would notice that closed loop wing has always been around. It's just a fresh take of closed loop wing, only the fact that there's an angular velocity to it.
So for conventional propeller design, obviously you can use sort of the idea of constant pitch, or you can use blade element theory, um, or Prandtl's lifting line theory, but all of them assume the propeller is straight and
Yeah, and there are loads of
assumes wingtip
approximations.
vorticity lift.
True.
Yeah, yeah. To my knowledge, there aren't any fundamental methodologies to design a toroidal geometry.
They aren't actually.
Um, so I guess, yeah, yeah. So I guess that was initially when I found your CAD model online. I was just curious on your methodology to creating that geometry. And obviously, I understand that you can't tell me a lot of things because that's your research and you wouldn't want that um, getting out. You could introduce to me having the spline geometry as a variable. Um, and I was wondering if you could talk a bit more about that and how I could implement that into my MATLAB or SolidWorks.
We sort of need a elliptical distribution as much possible, but then when it comes to a torus, it has to meet both the splines from both the blades must meet. So there is a compromise to it. Taking inspiration from zip line, something like that. It's very
Yeah, yeah, yeah,
novel. But the thing that actually got me is that both the blades are at different height. The fact is, when you have two blades in vicinity to each other, like take into account multi-blade propeller, they are not as aerodynamically efficient when compared to a two-blade or even a single blade design. The less the number of blades, the better. Aerodynamics say you that. The rear blade is always in the turbulent slipstream of the front blade. And the closer you put them together, and which you need in a toroidal concept because it has to be kind of closer to each other near the root, that's where efficiency drops. I was hoping if you could essentially change the height of two blades, one a little like maybe the rear blade could be like a little higher than than the front plate, and somehow they can meet in a torus. I've done that with my design, and I've got like really good results. If you notice in closed wings, they have the front wing at a lower plane and the rear wing in a higher plane. So they have this plane difference. So imagine the same thing, but in a propeller. I'll bet you have the twist distribution and thickness in control because otherwise you have loads of parasitic drag going on that could somehow be kind of weighed
yeah,
down. It's always like a tug of war between uh, the efficiency gained from reducing the vortex strength compared to the parasitic drag increase. So there's always this tug of war. So in order for you to win this tug of war, you have to choose these parameters very carefully. And in which
yeah,
case,
yeah.
spline design is, I would say it's top of the list because twist and chord, anyone can do. It's a piece of cake. The main thing comes in the spline design.
I'm sort of coming to you a few months too late almost because we're supposedly heading into the wind tunnels in about 2 weeks. So if I wanted to include spline design into my geometries, it would have to be within the next week, and then I'd have to get them SLA printed pretty quickly. And then yeah, we're going into wind tunnels, and then sort of over Easter, I'll be doing all the data analysis. And then the final dissertation report is due on the 4th of May. So,
That's
we've got time, but also
but not
time goes very
enough.
quickly when you also have
Yeah,
four other
no,
modules,
not
and
enough.
yeah,
MIT hasn't shared what kind of equations they considered when it came to this toroidal spline. I mean, that's what optimization is about. Like, you just have to hit the sweet spot. Well, when it
yeah,
comes to
yeah.
CFD solver, you have to be very meticulous in choosing the right solver. And of course, the mesh quality also takes into account. Are you going for a steady or a transient analysis?
I mean, I haven't looked at CFD a huge amount yet, because it's in my mind it's kind of like an optional. It's I feel like it would be going out of the scope of this project a bit too much. The entire aim is simply just to
Design and
um,
test is not it.
it's sort of an interest, but we'll also be comparing readily made toroidal propellers like Fox ears, donut toroidal propeller, which I've actually got with me. They've also included spline design, and I don't know
Yeah,
if you can see, but they do have the rear wing
the height
it bulges
difference.
up, yeah, which is
If
quite
you,
interesting. Um,
in some way, scan it, uh, get the point cloud, and somehow reverse engineer the spline to make your life easier, way easier.
hmm, yeah, that's good. That's not a bad idea.
There isn't much. People have just picked it out of the shelf and had a go on it.
Yeah,
There isn't much when it comes to this spline geometry, which I think is really essential because I remember, I think in my design there are like two ellipses, so both the splines are part of two ellipses, and I kind of changed the A and B, the major and the minor axis of both, and I kind of made like changes to the spline. Things change dramatically, power and thrust,
hmm.
which is when I realized the spline design is actually a very integral part of this toroidal concept, which not many people out there have focused on.
You obviously said that if you want access to the propeller, you should send you an email.
Hmm.
If you want, and it would be quite interesting, I can compare one of your propellers as well. I could test it in the wind tunnel, and I can send you the data,
Yeah, but
and
your
then
professor
I can
totally sent
reference
me a
you in
red
the.
flag on it. Your professor sent me a
Really,
red flag. Oh,
I think that was
okay.
just reflected in the email
Yeah.
sent to you, but slightly harsher, which I'm sorry about.
So I have two of my patents. We might use one of those patents. Yeah, I'm kind of an innovator. I have two registered patents, granted patents, and then third is underway, and then this. So I'm always thinking out of the box. And what you see in GrabCAD are literally things open to public, but I don't necessarily like spill out everything that's in Aladdin box, if you know what I mean. I don't spill out everything that's in the treasure box because what's the fun of it? Like when you kind of spill out your sweat and blood and then you come up with something only to give out in public. No, thank you very much. But maybe something which I feel like is worth sharing with public, then yes, but not everything. I mean, I was pretty active a decade back or something in Brack, and then I also deleted a few things which I thought might be risky putting it out on public because they were related to my previous workplace and defense and security stuff. Don't want to get myself shot at or being dragged to the court. Thank you very much. So those things are a little serious.
Yeah, yeah,
I really cannot speak out too much because I have to keep my, you know what I mean.
yeah.
So yeah,
Understandable.
I had to restrain myself. And the reason the reason I mentioned my email, because I wanted to keep track of everyone requesting or everyone I send it over to. Just because anybody drops an email doesn't mean I give it or share it with them. So I am very careful, at least these
Yeah.
days. So I would really tell people out there to be careful as well, because many people out of enthusiasm kind of feel like just being cool just drops out in public domain, and they kind of get in trouble. I have seen it firsthand. So, what I'm trying to say is, in your MATLAB program, you said like twist, and what was that? Chord. And chord, which means taper, because if chord is reducing, that means you're tapering it, correct? I would say freeze the taper, like freeze the chord distribution and play around with these parameters. It will really make your life a little easier, because if you have three major variables, it will make your life harder. Be
Yeah.
clever with choosing which design parameters you need to vary and which you want to freeze, and have a go at it.
Okay. Yeah, and that's also a good thing to talk about in the report at the end. You know, why I've chosen to freeze certain parameters. Well, I was going to say I've been building and racing 5-inch quads for about a decade now.
Mm-hmm.
So it's just kind of what's familiar to me. And you know, when it came to motor selection, it was somewhat easier because I knew roughly what I was looking for.
The thing I'm kind of skeptic about is that, like for a 5-inch, the disc loading is pretty high, and because of the viscosity effects, it can somehow outweigh the advantages of this design. That's my
Yeah,
intuition.
I definitely understand that
Because
the
kind of as you go
as you
smaller,
increase,
air gets more viscous, and it kind of may outweigh the advantages. So the larger
yeah,
you go, the more uh, profitable you are aerodynamically.
and
Yeah.
that's propped up a lot in my research as well. So yeah, it's definitely something to consider.
You mustn't actually, I mean, because you also fly fixed wings, right? So you could chuck this in a fixed wing
Yep.
as well. So you don't necessarily have to stick to
Yeah,
it.
true, true, very true.
Should you wish to like stay in aerospace and pursue research, that is.
Yeah, yeah, no, definitely, that'd be super cool.
The whole funda is essentially open book, so anyone can dig into it and get their own designs.
But thanks for taking the time to talk to
Yeah,
me. I mean,
definitely.
it's
Well, thank you for having me.